So, good afternoon, all of you. So, today we will discuss a topic named projectile motion. So, which is from the chapter motion in a plane. Okay. So, first terminology is here projectile. So, what is a projectile? So, this is an object that is in flight after being thrown or projected is called a projectile. Okay, projectile. And this is under the influence of gravity. Okay, so after being thrown or projected like, so you are projecting, or you are kicking a football, you are throwing a cricket ball, or you are throwing anything, or you are firing a missile also, that is also can be considered a projectile. But in case of a rocket, so when you are firing a rocket, if it's escape the earth, then it is cannot be a projectile, because it won't be under the influence of gravity. So anything within the earth surface or within the earth atmosphere which particle is influenced by the force of gravity is known as the projectile. So when it is in flight, okay, simply we can consider in a xy direction. Suppose this is your x, this is your y, and typically x will be your horizontal, x will be in your horizontal direction, and y will be in your vertical direction. Then object can be moved like this. Okay, so after some time, so the object will falls on the ground. Ground means here it is shown as schematically is the x-axis. Okay, so there are two components. Okay, so two components of the projectile motion, two components. So one component is the along horizontal axis. Okay, so projectile have a, suppose this projectile is thrown with a velocity v naught, initial velocity v naught, then this will have a two components. Okay, two components along x direction and along y direction. Okay, so that x direction is in the horizontal direction, and where the acceleration is 0. Acceleration is 0 means this velocity is v is constant, or that means the projectile velocity is constant along the horizontal direction. So if we resolve v vector, and if it is projectile is thrown with an angle theta with the horizontal or with the x-axis, then this can be written as the v naught of cos theta, and this will be your, then y part will be your v naught sin theta. Okay, and another one is the vertical direction. That vertical direction component is here it is influenced by the gravity. Suppose the projectile is thrown is like there, like this. Okay, so after a certain point its velocity becomes 0. So after that the body acts like a free fall under the gravity. So gravitational pull will be in the downward direction. So this acceleration can be written as minus g j cap, minus g j cap. Okay, so in vertical cases this acceleration will be your constant. So that constant is what? It is acceleration due to gravity. So in vector form we can write a is equal to g into minus j cap. Okay, g means its amplitude or its magnitude, sorry, its magnitude, and j cap is the unit vector in the downward direction. So if it is in downward direction, we put a simply negative sign. Okay, so this acceleration can be resolved into two components like ax I cap plus ay j cap, which further equals to minus g j cap. So from this equation we will have the x component of the acceleration will be 0, that is in the horizontal direction, already we have considered, and y component is a constant term, okay, which is nothing but your acceleration due to gravity. Now this v naught, now this velocity v naught can be resolved into two components, like v naught in x direction we can write like I cap with a unit vector, another one will be your poy j cap. Okay, so from this, if we consider two vectors like this, if it is your resultant, v naught will be your resultant. So two vectors are there, one x axis, one y axis, and along the x axis this will be your simply v naught cos theta, and in the y axis this will be your v naught sin theta. Okay, this is simple. And object is start from the initial position. It is suppose considered as a origin. Okay, so if it is origin, so we have equations. Okay, that equation is nothing but is your r is equal to r naught plus your v naught t plus half a t square. So from where this equations comes? From the motion in a straight line sector. So that straight line sector, we have s equal to ut plus half at square. Simply here, or you can write initial velocity v naught. Okay, so simple, you see this is your displacement, right? Displacement means final position vector towards the initial position vector. Okay, so that difference and v naught t plus half your at square. Okay, so if it is, we can write like this, put r naught in the right hand side, then we can resolve this equation into x and y direction. So the r is nothing but a position vector, so which can written as x I cap y j cap. Okay, so if it is like this, from this part, simply one can write x equal to x naught plus your v naught of xt plus your half a x t square. Okay, now consider this is x is your what? Initial position, that is origin, so this will be your 0. Then v naught of x will be there, and finally ex is along the horizontal direction. There is no acceleration of the projectile because velocity is constant, so ax will be 0. Finally, for the x time, we will have this term, which is nothing but your v naught cos theta naught multiplied by t. So this is your x component. Okay, x displacement, that is horizontal displacement in terms of your initial velocity of the projectile with the angle theta with the horizontal axis. Okay, similarly, for the y component, we can write y is equal to y naught plus y naught of xt plus half ay t square. From this equation, what we can write? Put this here 0. Okay, y naught of x given. This will be your v naught sin theta naught plus half ay means your minus z, then your t square. Okay, so simply you will have v naught sin theta. So I have missed the term t here. V dot sine of theta naught t minus of half zt square. So this is your y displacement, that is your vertical displacement, okay, along the upward direction. Okay, now your velocity vx. Okay, so this is your velocity along x direction. Simply instantaneous cases. Okay, it is ddt of x. X displacement was v naught cos theta naught. Finally, tt will be cancelled. So this term is a constant term. Tt will be cancelled. This will be your v naught cos theta naught. Then other one is the y direction. Velocity along the y direction. This will be your dy dt. Simply one can write v naught sin theta naught minus of gt. Okay, so differentiation of this will be half into 2 into gt. Okay, this is your 2 power. So 2 will come here. T will be remain like this. 2 will be cancelled. You will finally get this. So finally, the total velocity of a projectile, one can write v naught cos theta. So this will be theta, okay, not theta naught because we have considered that was theta. So v naught cos theta I cap plus v naught sin theta minus gt of j cap. So this is along your horizontal direction. This is along your vertical direction. So this remains constant. Okay, the velocity along x-axis along horizontal direction remains constant, but in case of vertical, the velocity changes. Okay, how? Like an object free fall under gravity. Okay, so when projectile is thrown like this, at this position your velocity will be 0. After that it acts like a free fall because from here this acceleration minus z will be acting. Okay, so now we have some kind of a other formulas or other terminologies like time of maximum height, time of maximum height. Suppose a projectile is thrown like this, so up to this position, this is your maximum height. Okay, so at maximum height, what will be your time? So whenever you are considering the vertical section, you need to consider your y component. So what we have? V naught sin theta minus gt. Okay, so consider to reach this position your time is tm. Okay, for maximum time. So at this position what? Your velocity will be 0. Okay, after that the gravity will start acting. Okay, so at this position your velocity will be 0. So if your velocity will be 0, your v sin theta is equal to gtm. Simply tm is equal to v naught sin theta by g. This is your time of maximum height. Suppose to reach this, you need to have time tm. Then to reach here, to reach the ground, so how much time you will have? Consider this is TF, 2 into TM. Okay, so this TF is called a time of flight. Time of flight. Time of flight means the total time required for a projectile to reach the ground after it is being thrown. Okay, so this will be your simply 2v naught sine theta by z. Okay, now maximum height, this to reach this position, how much height is traveled by the projectile. So simply this is also relation to the y component. So y displacement was your v naught sine theta naught t minus of half gt square. So to reach this height, so what we have, this is your tm, right, for these cases. So you simply write v naught sine theta tm minus half of z tm square. Okay, so if we put the value of tm here, simply, so this y displacement will be your h. So finally you will have h is equal to v naught sine theta whole square by z after calculations. Okay, I am not showing calculation here, so this calculation will be your homework. So you will finally reach this position. Okay, then one more component is called range. One more terminology is called range. Range means maximum horizontal distances traveled by a projectile. So maximum horizontal distance means key distance is equal to horizontal distance was v naught cos theta into t. This is your horizontal component, x component. Okay, now v naught cos theta naught, it was your velocity multiplied by time. So in these cases, this will be same, v naught cos theta naught, v naught cos theta. Okay, we are writing cos theta. And what will be time? Time means time of flight. Okay, total time required by the projectile, okay, to reach the ground. So what is 2v naught this time? 2v naught. So this will be your tf. So this will come as 2v naught sine theta z. Simply you see, this is v naught. Okay, so one can write and 2 here. So simply write v naught square by z, and here 2 cos theta sine theta. So 2 cos theta sine theta means it is v naught square by z sine 2 theta. Okay, so this is your horizontal range R. So hope you can understand the topic. So I think you will make a good note on that after reading the book also. So you need to study at your home also. Okay, so in the next class we'll do some kind of a numerical regarding these topics. Okay, so bye bye from the today class.